Okay, good morning, everyone. We are group number 6, consisting of Noha Abdeladir, Yusuf Bashir, Mohammed Shabshiri, Omar Mahdi, and Marwan Awad, and myself, Mohammed Ashraf. And we're proudly presenting our thesis project titled Classroom Monitoring Using AI under the supervision of Dr. Sharif Ali, and Dr. Hisham Ali. Next slide. Okay, so this is our agenda for today. We'll start by stating the problem. Why are we solving this problem? And then we'll talk about our proposed solution. We'll talk about our system from a high-level perspective. Then we'll move on, dig deep into the technical side of how we implemented our system. Then we'll move to the tough journey of collecting the data set, moving on to the results and demo, and we'll end with the conclusion, our limitations, recommendation for future work, and the business model. Next slide. Okay. So cheating is actually a problem worldwide, and unfortunately, Egypt is no exception. So based on our research, the alarming rate of cheating in Egypt has intrigued us to think about doing a system that might be helpful for educational institutions and might help create a safe environment. So based on our research and the fact that there are 23 million students in the pre-university stages, and with an average of 38 students per class, it might be extremely difficult to monitor exams. Also, we found that in last year's exams in Thanawiya Amma, there were 500 plus cheating cases during the examinations, and that intrigued us and helped us realize that we need a solution. So for our solution, we came up with an idea to develop a system that's backed up by AI technology, so to assist or aid the invigilators so that we can create fair and safe examinations for everyone. Moving on, we'll talk about our system. Noha will start talking about the high-level description of our system. Noha.
Thank you, Muhammad. So for the system features, it alerts a proctor of possible cheating incidents, and it allows the user to report it or dismiss it. It also allows the user to select the sensitivity for AI model. And finally, the system generates a detailed report and at the end of each session. There are mainly two types of users for the system, proctor and system administrator. Each of them has different levels of authorization. For example, a proctor can view possible cheating incidents, report suspected cases, dismiss false positive cases, assign AI model sensitivity, and view the end of exam reports. Whereas a system administrator can register a proctor, create exam instances, assign a proctor to exam. We divide our system mainly into 3 blocks. The first one is the hardware setup and the deep learning model. And the second one is the back end. And here we have 2 servers. The first one is EC2 and the secondary one is Heroku. And then they are connected to the database. And the last block is the front end developed with Electron.js. And now I'll leave you with Yusuf, who'll talk about the front end.
Thank you, Noha. So now with the front end, we have developed 7 front end interfaces for our system, consisting of the landing page, the main page, and the login page, which is followed by the confirmation page and the model sensitivity selection page, in addition to the end of exam report and the user logout. We will explain more in the next slides, and we will show a final demo at the end. For the development of the front end, we have decided to use Electron.js, which is a framework that is used by JavaScript to develop cross-platform desktop applications that uses different web technologies such as HTML, CSS, JavaScript, and Bootstrap. We have decided to use Electron.js to have the same code base to develop 3 different applications that can run on 3 different operating systems, such as Linux and Windows, Mac OS, in addition to having high app performance that is similar to the native apps that can run on these operating systems. Okay, so I will give you here a journey for the user throughout the system. So here is the landing page of the system, where the user can get to know more about our system and the developers of this system. For the proctor login page, the user can enter his login credentials that are provided by the system administrator, consisting of the user ID and the password. If the user entered wrong credentials or there is a mismatch in the information, an alert message should be prompted, and if not, the user should be redirected to the next page. For the confirmation page, the user will get prompted with these details, including the details of the exam that is assigned to by the system administrator, consisting of the exam instance, exam subject code, and the assigned camera IP in the classroom. If there is a mismatch in this information, the user should contact the system administrator to fix this problem. If not, the user should confirm and proceed to the next step. For the next step, the user should select the proctoring level of the system and the sensitivity level where the model will proceed and execute on. We have three values: the low, medium, and high, which corresponds to 25%, 50%, and 75% of AI model accuracy. The user should submit the value and then press start to execute the model. For the main page, we have here the monitoring panel. We have here the live feed from the classroom, and a notification will appear here with a new case with the ID. The user should select it and have any decision upon it, which is report or dismiss. At the end of the exam, the user should press on end session to end the examination session. So this is an example for the frame or a case that has been detected by the system of a possible cheating incidents. It shows here the case ID of the possible case, in addition to an image for the frame for the case. And then the user can decide on to dismiss or report the case according to his judgment on this frame. After the user ends the sessions, an end of exam report will be placed, including all the cases that has been decided by the proctor, including the cheating cases and not cheating cases. In addition to having the frame or the image of the case with the user ID, with the case ID and the timestamp to have a unique identifier for each case. And now with Mohammed to talk more about the back-end development of the system.
Okay, thank you, Yusuf. Now that we're finished with the first block of our system, which is the front end, we'll move on to the back end. In this part of the presentation, we'll talk mainly about our used technologies and our APIs. And for our APIs, we've subcategorized our APIs into admin level APIs and user level APIs. Excellent. So this slide actually is the summary of all the back-end development. We used Flask, which is a Python-based framework to develop our APIs. We used Heroku as a server to deploy on the APIs. We also deployed our APIs on EC2 instance, which is AWS services, one of AWS services. We also used S3 Bucket, another AWS service to store images. And we documented our APIs using open API specifications, i.e. Swagger, which makes our APIs more user readable and friendly. Next slide. Okay, so this is actually a screenshot of our APIs deployed on Heroku. As I mentioned, we here have, next slide. We here have user APIs and admin level APIs. While all the APIs are important, the most frequently used APIs, next slide, are these ones. For the admin level APIs, the admin, or in our case, the system owner, has the right to register a proctor, create an exam instance, and assign this proctor to this exam instance. Next slide. For the user level APIs, this is important to us so that the model, first of all, assign a model sensitivity based on what Yusuf just mentioned in the front end. The model also will create a possible case. We use the get recent case so that we can get the most recent case that just happened so that the user can take an action. And these actions are summarized into these two APIs, report case and dismiss case. And one of the important APIs also is generate exam report, which generates a summary of all what happened during the exam to help proctors and system user to monitor what happened during the exam. And now I'll leave you with Marwan to talk more about our core of our system, which is the deep learning model.
Okay, thank you. So we built our the core of the system, which is based on the Python script. The Python script mainly utilizes MediaPipe, a pose detection software built by MediaPipe, OpenCV, and TensorFlow. So first of all, we split a continuous video feed into single frames. We then split the video into corresponding threads to the number of students by finding their locations. We then process each frame by cropping out the location of the student alone rather than utilizing the entire frame of the feed. And then we process on 2 different stages. The first stage, which uses MediaPipe by detecting certain landmarks or identifiers on the human body, specifically the nose, left shoulder, and right shoulder. And we came up with a method to attempt to find a potential cheating case, which will be elaborated later on. And the second part, the second stage, if there is no cheating detected, is by running our own model, which mainly has 4 classes, but we decided to, for the sake of the model simplicity, summarize within the script into 2 specific models, which are cheating and not cheating. And within the cheating class, we have 3 different classes inside it. And then after that, if there is no cheating detected on stage 2 as well, we then alert the proctor. We don't alert the proctor, and there is a cheating case, we then alert the proctor. So a more in-depth look into the script itself is after we split the 5 seconds, we first check if we're in the first 5 seconds or not. If we are, we run an object detection algorithm called YOLO, which helps us find the students easily. We then find the number of students it finds. And within the first 5 seconds, if it finds more students throughout the 5 seconds than the previous current max number of students found, we then replace the locations and the number of students until the 5 seconds are over. After that, as mentioned before, we split processing into threads depending on the number of students, where each thread runs a specific student's process. And we enlarge the space a bit to account for any extra movement, whether it's through arm extension or leg extension. And then we run the first stage of MediaPipe, where we calculate the distance between the nose and left shoulder and distance between the nose and the right shoulder, where if the distance exceeds a certain number that we had found through trial and error, we can then assume that this person is either looking left or right. But if this isn't found, because not every cheating case can be found using only looking to the left and right, we then utilize our own model to try and attempt to find a potential cheating case. And if one is found, as mentioned before, we alert the proctor. And if not, we continue processing frames. And I'll leave you with Omar to talk about the system integration.
Okay, thank you, Marwan. After looking at each component of our system, we look how we integrated them. First, for the user, he has to log into in the front end and is authenticated through the back end. If the process is successful, the user can start an exam instance. When the user starts an exam instance, he then a feed is fed into the model, in which it tries to detect a cheating incident. And when a cheating incident is detected, the user is prompted on the front end to either report or dismiss the case, in which then it is updated to the back end. And this is a more detailed, but this is just a summary. And now Mohammed will continue with the data set.
Thank you, Marwan. So now we're going to move into our data set. But first, we're going to take a look at our setup. Next. So we decided to shoot our data set. We decided to shoot around between 4 to 10 people in AUC classrooms. We also got the approval of the institutional review board for the data collection process. Next. So we were able to collect around 100,000 or more frames, but we filtered out 41,000 frames that are distinct and useful for us. The data set was divided between 4 different classes: head movement, mobile phone, note passing, and not cheating. These classes were based on the research that we did, where we found out that these were the common cheating methods. We divided our data between 80% training and 20% testing. We also labeled and annotated the data using a library called LibImage. So there are some assumptions that we decided to follow for when we collected our data. First of all, we used a single camera setup that was placed in the middle of the classroom so that it can view all the students' bodies and poses. We also asked the students to act based on the four defined classes that we discussed in the previous slide. We also asked the students to face the camera or have their bodies facing the camera, like the image that you can see. We also assumed that the lighting conditions were stable and normal, similar to normal classroom like here. So now, so results, next. Okay, so the accuracy for most of our classes were relatively good, but the mobile phone wasn't doing so great. And our theory is that it's really similar to the not cheating class, and it's kind of snaky, so it can trick the model a little bit. But at the end of the day, we reached a good accuracy of 82.3%. Also, Marwan discussed the media pipe stage, the first stage. We trained it a little bit, and we got an accuracy for it, which was 84%. So now, or next. Okay, so this is the demo. First of all, you can see the back end on the left side and the front end on the back end on the left and the front end on the right. So the front end started, and when it starts, it alerts the back end and the model to start as well. So it was able to detect, YOLO was able to detect the correct number of students that was passed from the front end. And as you can see, there was, you can see that there was a cheating case that was detected. It was detected here by the model. And this was a not passing incident between two students. And you can see both of them, you can view both of them. And you can choose to view both of them. And you can choose, like Yusuf said, you can choose to dismiss or report the incident that you can see. At the end of the exam session or at any time, the proctor can end the session at any time and view the exam report and all the cheating incidents, all the details that Yusuf discussed, the image and all the other details, the class and everything. So now I'll leave you with Noha to talk more about the conclusion.
Thank you, Muhammad. For now, we're finalizing the research paper. Our main goal is to publish it in one of the venues of IEEE. We're still deciding which one, so we'll start in the process once we finish it. As a commercial product, we're also finalizing the business model. We already contacted several educational institutions to offer our product. We believe our main limitation is the data set, so we need to increase its size with multiple camera setups and various participants. We also need to get real data from schools instead of doing it ourselves. Another limitation is that YOLO is very slow when used on CPU, and sometimes it's limited by the number of people in the frame. So for future versions, we might use SSD multi-object instead of YOLO. One last limitation is rather than processing frames in 1 second batches, we need to develop an approach for multiple seconds with single output. And now Omar will talk about the business model.
Thank you, Noah. And now I'll talk about our business model. As an anti-cheating product, we target the education sector mainly. We wish to target schools and mainly the Ministry of Education here in Egypt. We found that there aren't many competitors here in Egypt. Most of them are global. Like for here in AUC, we use the responders. So we're competing. Our competition is not very high. So our main goal now is to utilize this and to have a rapid expansion strategy. So our pricing that we chose is to use a subscription and instance-based model in which users can. In which the institutions can choose to either subscribe by a weekly or monthly basis or by a certain exam or the number of exams they wish to choose. And it will be strategized by using different price points based on the number of students in the exam This is to allow the software to be affordable to all the institutions, and also will provide a basic and premium options in which the basic is a cheaper option and provides limited features. Next slide. So for our business objectives, we wish to have our software as an open source platform to enable us to be a trusted and secure software. So we believe that we need the most important thing is a patent acquisition in order to ensure that our software is not mimicked by someone else. And also as we already know our customers, they are well listed and we are B2B. So we don't need a lot of financing for marketing. And the research and development is also highly not financially consuming for us. So we believe that we will be very financially sustainable. Next slide. So thank you. This is concludes the end of our presentation. We would like to thank firstly our advisor, Dr. Sham and Dr. Sharif, for all the guidance that you gave us throughout our journey. We would also like to thank our colleagues, our parents, and all who helped us to achieve today where we have come. So thank you.